Okay, this should be the last video for the Chapter 6 C1 sequences and series questions. Okay, question 15. We're actually invited to write down two equations. So here we know that we're going to be using simultaneous equations. So we've got the 18th term, U18, is 25. And we know that this is a add n minus 1, which is 17d. That's our first equation. And then we're also told the 21st term, u21, is 32 and a half. Not a nice number. And that also equals a add 21 take away 1, 20d, giving us the second equation. So that's part A done. Part B says show that A is minus 17.5 and find the value of D. So we're just going to have to go ahead and solve these two simultaneous equations. If we do equation 2 take away equation 1, we're left with 15 over 2 equals 3D. So we get here D is 5 over 2. If we then stick this back into equation 1, we get left with 25 equals A add 17 times 5 over 2. So we get left with, when we rearrange it, A is minus 17.5, which is what it said in the question. I might have missed out a couple of steps here, but I'm sure you can persevere. Okay, part C says the sum of the first n terms is 2,750, and we need to show that n is given by this. It will help later on down the line if you know what this number is. 55 times 40, if you do 55 times 4 and then multiply it by 10, you get 2,200. Right, let's go down where there's a bit more space. Part C. We have that Sn is 2,750, and that equals n over 2, 2 lots of A, 2 lots of minus 17.5, add n minus 1 times D. Not great numbers to work with, but we'll just keep persevering. 2,750 equals n over 2. 2 times minus 17.5 is minus 35. This becomes add 5n over 2 minus 5 over 2. Now, if we put them all over 2, this becomes 2,750 equals n over 2 minus 70 over 2 minus 5 over 2, add 5n over 2. We've got n over 2 times minus 75 over 2, add 5n over 2. If we bring out this 2 that's in the denominator, we've got n over 4 minus 75 add 5n. If we multiply the 4, we end up with 11,000 equals minus 75n add 5n squared. We can divide everything by 5 and bring it all over to one side, and we get left with n squared minus 15n minus 2,200, which is exactly what we wanted in part C. In part D says, hence, go ahead and find the value of n. So even if you couldn't do part C, you could have maybe got part of the way through, you just go ahead and use it in part D. So we're going to factorise it, and it gave us a nice little hint in the question because it said that 55 and 40 were factors. So we've got n minus 55 and n add 40, so n equals 55 and n equals minus 40. Can't have a negative term, so n will just be 55. Okay, last question, number 16. Okay, so first year 1951, last year, year 40 is 1990. 1960 is the 10th year. 1990 is the 40th year. So UN, so U10 is A add 9D, and that equals 2,400, and U40 is A add 39D, which is 600. We need to find the value of D and find the value of A. If we do, what should we do? Should we do equation 1 take away equation 2? So we have 9 take away 39, which is minus 30D, and 2,400 take away 600 is 1,800. So that leaves us with D as minus 60. And then to find the value of A, we'll stick them back into equation 1. So we've got A equals 9 times minus 60 equals 2,400. So A equals 540, add 2,400, which is 2,940. Lastly then, part C, it wants the total, so we're going to use Sn over the 40th period, 40-year period. So S40 equals 40 over 2, 2 times A, which is 2 times 2,940, minus 39 times 60. So we do all these calculations. I could do them all to the side. If you persevere, you should get that the total is 70,800 houses. Thank you.